Haystack 3.0 ships with skills, the same skill.md format Cloud Code and Codex use. A skill teaches an agent how to do something. It doesn't give it any new abilities. For that, you still need a tool. My name is Kacper and I would like to show you how you can use both in your Haystack agents. In this video, you will pair the Caveman skill, an existing ready-to-use skill that makes an agent answer in an ultra-compressed style to cut token consumption. With a custom tool, you write yourself and see whether it actually changes what the agent does, not just claims to do. Everything here runs fully locally with Olama. No API key needed. You will use a tool-capable model, and the whole agent is async, so in Jupyter you can just await it directly. Rather than writing a toy skill from scratch, you will drop an existing one built specifically to cut token consumption. Caveman, MIT licensed, which makes the agent respond in an ultra-compressed style. Its description literally say it auto-triggers when token efficiency is requested. That's the hook that lets the model decide on its own whether to use it. Run that cell, and this is all that prints. That's it. No skill content has been read yet. The toolset only knows a skill called Caveman exists and roughly when it's supposed to apply. Whether it actually loads it is a decision that agent makes later on its own. Before adding anything else, let's isolate that decision. This next agent gets the skill and nothing else. No bash tool, no machine access. And the question has nothing to do with the system inspection at all. We asked it, I need my replies to be as token efficient as possible from now on. It loads whatever skills helps with that and then answer what is Docker and why do people use containers. If you watch the streaming output, you will see the model call load skill on its own before it says a single word about Docker. Nobody told it which skill to load or even that it should load one. The description alone was enough to trigger it. That's the whole idea of progressive disclosure, proven with the simplest possible example before any custom tool gets involved. A skill can only teach. It can't act on its own. So you will pair it with a small custom tool, a bash tool, a tool subclass with sync and async run methods, plugged in with a name, a description, and a parameter schema. That's the whole custom tool story in Haystack. Haystack deliberately ships no built-in shell tool, since running arbitrary commands is inherently risky, so scomping it is on you. And before anything executes for real, a human-in-the-loop hook stops the agent and asks for your approval on every single call. This is really a lesson in building your own tools safely, with the skill just riding along on top. Now for the real test. You will run the same exact task twice. Investigate this machine, OS info, disk space, largest files. First, with a plain agent. Then, with the exact same agent, same bash tool, same confirmation hook, the only difference is the Caveman skill is available to load. You won't force it. You will just add one phrase to the second prompt. Make this as token efficient as possible, which matches the skill's own trigger condition. And here is the comparison that matters. Not the total run tokens, since that's mostly about how many tool calls got made, but the final answer tokens. How much you actually end up reading. That's the pairing. A skill the agent decides to load on its own, based on a one-line description, plus a custom tool that actually does the work. And you get to measure the effect instead of just trusting it. Neither piece needs the other to exist, which is the real point. Write your own tool, drop in any skill, and then compose. If you want to try this yourself, the notebook's linked below. It's a part of this week's lunch drop. Thank you.